To create the player physics, a player class was created that uses the current velocity to calculate position and updates the camera accordingly. The player's velocity changes when pressing the W, A, S, and D keys. When spacebar is pressed, the player's velocity in the Y direction increases as the player jumps. A grounded state determines whether the player is currently on top of an empty block or a filled block. To detect collisions, ray marching is used. Rays are marched from the vertices of the player's bounding box to the direction indicated by the velocity. If a collision is detected, the player is moved back to their original position. A fly mode is also implemented, in which the player is no longer subject to gravity or collisions.
The procedural terrain portion of the project included using FBM to create a multi-layered terrain as pictured. In an earlier version of the code, you can see clearly that the 256 height blocks consist half of stone, then dirt, then the top block is grass. Next, the player is able to left-click on a block or within a block's distance and remove their desired block. This is found by casting a ray and finding the appropriate block with the smallest t or intersection distance. This is done by looking at the three directions surrounding and calculating the t's. They can also right-click and add a block as seen here with the addition of lava. This is done the same way, but the player has a 2 or 3 unit distance to add. Finally, as you move along the X and Z axes, the terrain expands. You can see a shift in the height of the terrain and an addition of terrain as the camera moves across. This is done when the player or camera moves to 4 blocks away from an edge.
For the efficient terrain rendering portion of the project, we've broken up terrain into 16 by 16 by 256 chunks, so that we can just render the chunks that our player has explored, rather than rendering all of the terrain in the world at once. Instead of rendering every single block in the chunk, we're only going to render the blocks that would be visible to the player, that is, the blocks that are adjacent to empty blocks, which form the exterior of the chunk itself. Additionally, if they're on the edge of chunks, and they would be adjacent to another block, they will still be hidden. I've also implemented interleaved vertex buffer objects, which go position, normal, color for each vertex. Lastly, because we're rendering chunks individually, we're able to tell which chunks lie in front of the camera, and only render those. Additionally, we de-render chunks when they get too far away in front of the player.